All right, so let me show you how to use this thing. Say that we got a box, and Julia, you're pushing this box along the floor. You're pushing with a force of 82 newtons. And you want to move this thing a distance of 3 meters. How much work did you do? All right. You're pushing this thing with a force of 82 newtons. You want to move this thing 3 meters. What you did was you said, all right, to find the work, you just simply multiply the two numbers. So that would be 82 newtons times 3 meters. And that would give you 246 newton meters, also known as 246 joules. So technically you would have done 246 joules of work. It's that simple. It's just straight up like that. You just multiply those two. But here's the thing, all right? It's not always that simple. And they give you an equation that kind of pisses me off sometimes. Really what they say is they're going to say something like this. Another equation that you're going to see, and this is not a different equation, but you're going to see this. Work is equal to force times distance times cosine of theta. All right? Now, here's the scenario in which this makes sense. Say that instead that you take your box, and what you want to do is you want to pull this box at an angle of theta degrees. So you want to pull this box at an angle of 30 degrees. You're still applying the same force, 82 newtons. And you want to move it 3 meters. How much work would you do in that case? How much work is done in this case? All right. What's going to happen here is actually you're going to be doing less work or more work. No, the amount of work that's done is less work. Because your 82 newtons is actually going to have an F of x component and an F of y component. Now, if we want to consider the F times d, what you really kind of should consider is the amount of work that you do is equal to the force that is in the same direction as the distance that you're moving times the distance. And the force, the component of the force that's in the same direction as the distance you're moving is the F of x. So in this case, F of x equals F cosine theta. And that's where they end up getting the work is equal to F of x times d, which is work is equal to F cosine theta times d, which is the same as F d cosine theta. The reason why this pisses me off is because of this. That's true. But what happens if you define theta to be this angle right here? You see what I mean? If you define theta to be a different angle, the hard part is this is no longer true. This is actually F sine theta. So this equation works as long as you define the angle in a very specific place. What I'd rather you do is just understand that work is equal to force times distance. Maybe I should say Fd times distance. It's the force that's in the direction of d times your distance. Now, there's this thing in vector calculus, yes, I know, where you'll have Fd cosine theta, and it all works together, and it all will make sense. But for now, what I'd rather you understand is I'd rather you understand how to work this problem and not just blindly plug it into this general equation, Fd cosine theta. I'll admit to you, I mean, like if somebody's watching this video and they say, wait a second, don't you understand the dot product and cross product and all of that kind of stuff? Yes, I'm a physics major, I understand these things. There's a reason why we have Fd cosine theta. But my point is, for the beginning understanding of your brain, what I'd rather you do is be able to analyze this thing. So your Fd cosine theta, depending on whatever theta is, you just plug in your different number for theta, take the cosine of that and multiply that times the force, multiply that times the distance. Does that make sense to you? Like, for example, what happens if I did this? Instead of pulling the box, I push the box. Well, all of the work that is, all of the force that's being pushed, and I say this, it's being pushed at an angle theta at, 20 degrees below the horizontal. This would be my angle theta. The only part of the work that's doing any work is the f of x in this case, and you're moving in a distance d. So in this case, your work is equal to f d sine theta. Because the way I actually, oops, cosine theta. Because I define theta to be this angle, f of x is f cosine theta, multiply that by d, that's where you get f d cosine theta. We cool? However, if I define the angle oddly, and I said, well, what if the angle was this, theta, then it would be work is equal to f d sine theta. All right, I've got one more question for you. Say my wife used to be a waitress, and she used to carry around drinks on a platter. So let's see, here's the platter. Here's the drinks. Here's a straw. There's a little umbrella. All right. So my wife used to carry around drinks on a platter like that. She used to hold it up there. And she used to walk around and all that kind of stuff. How much work did she do? How much work is she doing? She doesn't raise it up or lower it down. She's just moving it around. Okay? So it's moving around. How much work is she doing? Well, her force is actually going this way, right? Her distance would be moving this way. Which component of the force is moving in the same direction as the distance? None, really. So technically, I guess the question is, how much work did she do? By this definition, her work is zero. I mean, yes, it did take her work to be able to raise the tray up in the air, but once she got it up in the air and she's keeping it at the same height, technically she's not doing any work. The point I'm trying to make with this little comment right here is don't confuse the idea of work like working, like what you would get paid salary for, with the physical concept of work equals force times distance. They don't relate really to each other. It's just it just so happens that we chose the same word as working part. So technically, why should we pay waiters and waitresses anything if they don't do any work all day? I mean, don't say, oh, a waiter or waitress, I said that, but I'm just saying. If you think about it, they didn't do any work on anything. I mean, raising it up and lowering it, that's not a whole lot of work. Yeah, I'm going to probably be in trouble for that comment.